so this is video 2. Name the parent function and domain of the function. And look right away, it's x over 3x plus 1. It's a polynomial or polynomial. This is a rational function. So now we got to do the domain. Now, you could do the domain by simply looking and knowing that the bottom can't be 0. So 3x plus 1 cannot equal 0. And we can see quickly that's negative 1/3. So the domain is x is an element of reals. X does not equal negative 1/3. It is part of a parent function, though, and again, I want to be clear about this, of 1 over x. And actually, if you take 3x plus 1 and divide it into x, you can do polynomial division and rewrite this function. And if you rewrite this function here, you can see here that it's shifted up 1/3, and you can see here that x can't be negative 1/3. Remember that this mirrors it, and if I wanted to do a quick sketch of that graph based on that polynomial division, I could draw in asymptotes at x equals negative 1/3 and that 1/3, and then it would be mirrored because of the negative 1/3 compressed. Second one, again, you look at this, at 5x plus 4, a line over, which is a polynomial, over x squared plus 3x plus 2. Again, a polynomial. So it's polynomial over polynomial. It is a rational function. In this case, we always want to factor, and I factored it over here. And I can see three things when I factor. I can see that the domain is all reals because it's rational, but it can't have the bottom be 0. I also can see that there's a 0 at negative 4/5. Next one. All right. We have f of t equals square root of t plus the cube root of t. All right. If we think about our parent functions, we have the blue square root of t and the cube root of t. Well, you are limited by the smallest domain, and the smallest domain is this one. So this time, x is an element starting at 0 and going to infinity. We can't use negative numbers because this part of the composite function is limited. Now, I agree it's 2 roots, but they're combined. So likewise, on the second one, it's 2 root functions, all right? A single root function and a single root function, but this is a composite. And again, the domain of this portion would be 0 to infinity, but that is not this one. And again, sometimes students prefer to think of it this way. We know that this has to be greater than or equal to 0. So negative w is greater than or equal to negative 6. Divide by negative, flip the inequality. And w has to be less than or equal to 6. But over here, and I suppose this is an x, this is w, we know w has to be greater than or equal to 0. So the question is where do these two inequalities overlap? Well, greater than 0, less than 6. So we know that the element of this function is 0 to 6. Last one today. Now you might see this and say, oh, polynomial over what looks to be like a polynomial, but if you look there, it's the 4th root. So this is a composite function. And now we got to find its domain. And when I do this, I want to make sure we're clear that when we think of the 4th root of x down here, and I factored the inside, we have this going on. And you notice the other thing I did is I actually graphed the parabola. Well, I know the 4th root of x has to be 0 to positive. So whatever this is, x squared minus 2x that I have factored, has to be greater than or equal to 0. Well, where is that greater than or equal to 0? Well, I made the graph here so you can see it. It's greater than 0. Well, it can't be 0 because it's on the bottom. It has to be greater than 0. Sorry. And it's greater than 0 there and there. Well, the output of x squared minus 2x, the range of it that's greater than 0 is negative infinity to 0, not including, and 2 to infinity, not including. And when you plug those values in, you'll have a positive number to the 4th root, which will have an output. So that becomes the domain. Again, this is a quick video. If these are confusing, you need to do more practice.